Well, the company is at Ultima Capital Partners, and it's my pleasure this morning to explore the critically important subject of zero energy buildings. UCP, Ultima Capital Partners, is engaged in these markets, and so most of what I present today is based on our actual experiences. In today's presentation, we will focus on zero energy buildings, available approaches to achieving ZE. As well, we will review case studies based on metrics and conclude by highlighting some of the challenges to achieving more. The zero net energy consumption principle is viewed as a means to reduce a carbon emission and reduce dependence on fossil fuels. Although zero energy buildings remain uncommon even in developed countries, they are gaining importance and popularity. At times they consume non-renewable energy and produce greenhouse gases, but at other times reduce energy consumption and greenhouse gas production elsewhere by the same amount. Typical zero net energy buildings get half or more of their energy from the grid and return the same amount at other times. This is straightforward. Zero energy offers a substantial opportunity to reduce CO2 footprint and to reduce energy intensity. This map from the University of Illinois is an excellent illustration of the systems approach. And I'm not going to go through every part of this. We have a set of slides. They will be available to everybody. There is quite a number of detailed slides that we will present, but they're there for your future reference. So anyway, from including here photovoltaics, chilled beams, heat recovery chillers, water efficiency and much more, all to be featured. So zero energy is about balance. Measurements about inputs, outputs, loads, offsets. Many technical items need to be accounted for with accounting methods. And the time period also is of relevance when reporting. There are also quite a number of constraints, and I've listed some of these here that relate to the grid, to the buildings themselves, and also enablers. So the constraints just aren't technical or economic, they also include people at many levels. Zero energy buildings in the residential sector, again a slide courtesy of General Electric. It illustrates the ZE approach in the residential dwelling market, which is very large, great opportunity. It's also an intensely ICT-enabled systems scenario. There's a lot of people working in this space, a framework for many devices, solutions and participants. Some of the businesses that we've invested in, a company called EMSC Asia Pacific, is a company that has an exposure to zero energy buildings. It's a provider of the power star, voltage, optimisation, energy storage, and demand and supply side solutions. Smart Utility Services is a provider of energy monitoring and power quality solutions. Ultima Capital Partners, from which I'm speaking today, is a provider of structuring and financial solutions for energy projects. And Ultima Grid Solutions packages all of the above projects and services with energy performance contracts and managed service agreements for LV and HV infrastructure. So reducing the carbon footprint. All of the solutions we see are designed to impact on energy and carbon footprint. And we see the journey for many clients commencing with demand-side energy efficiency on the left, with the traditional energy efficiency savings initiatives, the key options shown that are being used. The next important yielding investment is to focus on power delivery. Our focus there is on voltage optimisation, power quality, storage and cloud monitoring. And beyond that, of course, is the integration of generation, distributed generation really, and we're familiar with those options. The energy efficiency menu is large, and within the building envelope, energy efficiency steps may be taken to reduce energy demand. I've listed 10 of these here with various projected payback periods. This is information from the market. It's a crowded market with most capable vendors making offers. I'd like to focus a little more on one of those, being voltage optimisation, as it affects all of the loads that are powered electrically through conditioning the power delivered to the site. And for those of you unfamiliar, I'm not going to go into all the details of voltage optimisation, but it is about reducing the incoming supply voltage effectively to the nameplate voltage for the equipment at that site. And in so doing, not only is the power quality enhanced, but the energy consumed by all loads will be reduced, and generally significantly. Now that solution is gaining traction with ASDA, Walmart's UK operation, having installed PowerStar voltage optimisation in over 540 retail sites in the UK alone, based on their very positive experience of energy savings, reliability and cost reductions across their retail fleet. ASDA are working with us now to commence deployment of further products, including energy storage solutions, and I'll take you through those today. Okay, and voltage optimisation at the low voltage side, the company PowerStar, you may have heard of that brand, is the leading international vendor of voltage optimisation, offering solutions that have a number of fixed taps or alternatively fully dynamic solutions. These are designed for installation on main switchboards, which we've illustrated here. Unit sizes from say 300 kVA up to in excess of 3000 kVA offered, and typically we would see in installations in commercial and industrial sites savings of about 15% kilowatt hour reduction. Now at the high voltage supply, these products also offer fully dynamic solutions, and it's a unique product globally with this technology. The equipment is designed to operate up to 56 kV incoming supply, with unit sizes of up to 4000 kVA offered. All of these solutions utilise ultra-low loss amorphous core transformers for additional energy savings of typically between 3 to 5% when replacing aged high voltage transformers that might already be there. The case study shown is based on a number of PowerStar installations across a portfolio of a particular client in the healthcare scenario. The diagram on the left chart shows the savings with a 50% return on investment. On the right is the same scenario utilising project financing. The client has no upfront capital requirement. The installation is paid for over 5 years with a small residual payment at the end of year 5. And even so, this scenario is positive cash flow for the client from commencement, as the savings are well in excess of financing costs. Now, over a 10-year period, this client will have accumulated a net cash benefit of $20 million, will own the installation, and will continue to reap further cash flow benefits for years to follow. So this is one of the cornerstones of the PowerStar voltage optimisation energy solution. I'd like to move to the next point, which is about the application of utility scale storage. This has benefits for managing tariffs, maximum demand, as well as allowing more harvesting of solar photovoltaics. The benefits are also there for other stakeholders, as large storage may be regarded as distributed generation. This diagram depicts the operation of the PowerStar Virtue system. The key components are, and you'll see this on the diagrams in the upper left corner, a PowerStar dynamic voltage optimisation system, a storage solution, load controller, and a master controller. Now, power can flow from grid supply, from battery or PV to the load. Battery can be charged from the PV or from the grid supply, all under managed control. And the PowerStar Virtue allows companies to save and store electricity locally and switch to this stored supply at any time. On-site renewables can therefore be integrated with the PowerStar Virtue solution to provide the maximum cost benefit from renewable generation. Now, an application of this solution is being adopted by ASDA, who are deploying a large-scale integrated solution at an existing superstore in the UK. And the system addresses distributed energy storage in this type of application or in any other commercial and industrial application. It certainly makes the most efficient means of integrating battery storage into power delivery. So the Virtue system is quite unique in this regard, as it integrates voltage optimisation, either LV or high voltage grid tie transformer solution. Certainly is about making renewable energy more reliable, and particularly in distributed energy management scenarios. What does it look like? Well, that's the product. It's modular in a containerised format. It would be located adjacent to a building. And if we zoom in a little bit more, we'll see a site of the ASDA store and the installation of the Virtue package. Close proximity, but external to the switch room. There are many benefits from the use of on-site storage, and I'm not going to go through all the details on the slides. They're there for your future reference, but just listing those key topics: UPS functionality, CO2 reduction, renewable connectivity, energy cost reduction, smart grid integration, and possible potential income sources therefrom, and electric vehicle charging. I'll talk about that too. There are other benefits that flow from the adoption of on-site storage. Now, these will relate to the client's own business model as opposed to generic features. For example, in some industries, the cost of process interruption avoided will support paybacks of less than 1 year. And replacing UPS in commercial facilities, in this case a major European retail chain who've commenced deploying this Virtue solution. We've opened up all the cabinetry there in its fine glory. They are replacing the shop and emergency lighting with just one LED solution. So house power is now effectively large-scale UPS through a PowerStar Virtue solution. And by eliminating duplicated infrastructure, they've achieved a payback period of less than 5 years. This is also providing for them enhanced energy security for their continuing operations. These systems all are provided with a 15-year warranty. So Virtue is quite new. Many of its componentry or subsystems are patented. It utilises what we call the negative power benefits of PowerStar's also patented voltage optimisation. And Virtue enables distributed demand to become nodes in efficient distributed storage. The project with ASDA sets the scene for future rollouts, and they're occurring not just with ASDA but with some of their competitors in the UK as well. ASDA's application was for a 3 megawatt hour retail superstore in the UK, and this enabled all of the electrical services to continue off-grid at peak loads and in brownout conditions. This is quite a unique project in the UK and is being conducted at present in collaboration with the utility E.ON Energy and Warwick University for independent verification and reporting of the entire project. So far I have addressed voltage optimisation and energy storage. They interact in a zero energy building solution to deliver further benefits. We estimate that our solution can reduce the cost of initial renewable installations by up to 30%. Our studies have shown systematically that integrating PowerStar voltage optimisation into any PV-only solution will reduce the payback period by more than 1 year. So coupled with Virtue, the benefits are not only financial, but also reliability of supply. And here we have a number of case studies that I'll flick through some of these slides, but they're there for your reference. Now, this case study presents before and after for a voltage optimisation plus PV and storage solution. It's an ICT data centre providing services in the Australian telecommunications industry. It's real energy data. On the right, we show the immediate energy reduction from deploying voltage optimisation alone. And then we move along, and we have a zero energy building opportunity. So the chart on the right is showing, when you get your printouts, you'll see that the net energy cost of this building was zero. So the solar PV is being fully harvested and used to charge the battery and to export to the grid in a virtual network mode. And that right, as I've said, the net position is zero. As well, there is no grid power consumed at all at peak tariff time. So a number of simulations follow. We look at the energy sourcing and the energy sinking so that we get an understanding of how these systems work. These are provided for your reference. And you'll see from a load energy analysis, the charts illustrate the source of energy consumed by the site load. The voltage optimisation and storage, if you like, account for more than 25% of the consumed energy, and the grid supplies less than 30% of the energy consumed by the load. Of course, the grid is supplying also some charging, and also the overall equation includes losses from all of the electronics and system components. Now, these charts show that the import and export of energy between the site and the grid. Note that there is no import at all during peak. In this simulation, the site does not export significantly, but could be scheduled to do so. Now, there is a market for that, and this is an ideal zero energy building example. And of course, the simulation here of this site includes the CO2 savings from reduced energy imports. This is a very significant impact on CO2 reduction. A second case study is a dairy processing plant. Again, real energy data on the right. We see the effect of voltage optimisation by itself, and as we move through, it's almost the same type of message that we saw previously. The way this particular one has been set up is just a very small consumption from the grid, but effectively about net zero energy. The system could be further fine-tuned. There are so many objective functions that one can pursue. Kilowatt hours, dollars, and various operational parameters. CO2 savings, again, quite significant, and what we'd see here is that the CO2 savings that are provided by the voltage optimisation component itself are about 15%, and you'll see that in the sort of the lighter blue colour, but the other components and aspects of the system are well shown. With this dairy processing plant, the site achieved a zero energy outcome using the equipment configuration, 350 kVA voltage optimisation, PV of 500 kilowatts and storage of 500 kilowatt hours. A return on investment of 17.3% was illustrated. And the response surface that's shown here illustrates variation of payback by modifying equipment configuration. This particular client that we're working with at the moment is critically interested in non-stop operation of the site. System energy savings of note is the cumulative energy savings. So for this site, the total capital investment would be under $2 million for a complete energy solution, and the savings are significant and of course are ongoing. And looking at the cumulative net cash flow in a leasing situation, this was a 7-year lease. You can see the residual there. That could be refinanced anyway to make that bump go. And the key observation that we should all take out of this is that it's positive cash flow from day one. And again, if we just look at the annual surpluses retained by the site owner, the equipment in a rental situation, as this is, rental model is an off-balance sheet financing approach. Again, the solution is positive cash flow from day one. Quite exciting for the plant operator considering the non-financial cash flow benefits that they achieve, and the green benefits and others. This third case study is a higher education facility. So this one again is very similar to the others. This one is showing a small negative energy net position. Quite interesting. So that again is a zero energy building result. Now we've got a number of these charts here. We can look at those again later, and the same conclusions are reached. This solution is cash flow positive from day one. Quite good. Another application that I'd like to dwell on just for a moment is lift systems, where storage is quite beneficial because the storage can be integrated with regenerative motor system used in lifts. Now the side benefit of this is that the zero energy application, the storage component of it, can provide a full UPS capability to that lift system in the event of supply failure or interruption. So this case study 4 is a lift system, but it's an inverted lift system, so it's only an upside down lift. We have here an Australian ecotourism company called Sky Leisure, who plan to deploy a virtue-powered tethered observation platform to carry 15 passengers at a time to more than 200 metres, up to 400 metres in altitude. And this will be deployed in the Northern Territory near Uluru, and many other sites internationally after that. So the system is off-grid, entirely renewable power, and it is configured to provide all site power. It operates remotely. And what we see here in these particular charts is that the system, which is based on a 500 kilowatt hour storage solution and a PV array, compared to the alternative diesel system that it would have otherwise replaced, offers a superior cost of ownership. It also has the ability to deliver additional energy at zero marginal cost. So when financed, it operates at about half the monthly cost of a diesel solution on a cash outgoings basis. Plus it's green, silent, and has no smell. So in summary of the benefits of utility scale solutions, Virtue's being now proven at significant sites in the UK in a number of sectors, and we're gearing up for its deployment here in Australia and in the other 16 countries across Asia Pacific where we operate. These systems come with a 100% energy savings guarantee to the extent that that has been measured and assessed prior to the project's commencement. And we're currently working towards our first major large-scale trial in Australia. It might be a replicate of the ASDA trial, or it might be for an off-grid cold store application. So we're currently working through that at the moment. But Virtue also opens up a number of other applications, and I mentioned in an earlier slide about EV charging, and already we have a number of vehicle fleet operators who are faced with challenges of how to charge up their commercial distribution vehicle fleets when they're in loading docks at peak times. Very substantial supply on grids and not able to be served. So again, a storage solution comes into its own. So for smaller vehicles, we have a product here, and I'm just going to allow the pictures to do the talking here. But these are fast charging systems for curbside use. We also have other solutions that are intended for retail applications. These products all have inbuilt demand response functions, including flexible demand, firm frequency response, and electricity demand reduction. We focus in on the small fruit logos. We'll see that we're also working with large MNCs who are trying to encourage their staff to adopt electric vehicles for their work transit of a day, and so now are preparing to deploy reasonable scale, rather sophisticated arrays of charging pods. And the systems we have here are based around a 400 kilowatt output, 400 kilowatt hour storage, EV shelter systems. So arrays of these effectively served by 400 kilowatt hour storage units, so these will be banked severally across. There are other applications of our products, and I've really concentrated on what I would call the demand side, but equally well on the utility side, on the supply side. Utilities are expected to accommodate very heavy investments in demand side resources and distributed generation. Thank you. Yeah, often under existing and unfavourable revenue frameworks. We have solutions and we're gearing up for trials with utilities. We're also involved in preparing and enabling the zero energy home with Internet of Things, smart metering and energy management technology, currently through patent phase, and we're quite excited about bringing these solutions into the near future. Well, for many customers who have fleets of facilities, our company is involved presently not only with Australian firms but multinational corporations, bringing the possibilities of zero energy buildings to reality. So we're working to bring forward fleet financing solutions. Now, the key points for these are summarised here, but they include off-balance sheet funding, a master agreement that provides for flexible deployment across jurisdictions, country, and location of facilities, energy guarantees that underpin positive cash flow outcomes, that is to guarantee the business case, and other energy assets that might also be put into the asset pool. So I'm not going to go through these details, but they are here for your reference. And as also we're involved in energy performance contract design and structuring, and we tailor these to the unique requirements of our individual customers. Now, bringing this presentation to a close, I note that not only in the area of our own work, trying to facilitate the adoption of the relevant technologies within our clients, but more widely, HVAC solutions are of great interest to us because our solutions, energy solutions, power the HVAC. Much more can be achieved. It's a huge opportunity, as Tim has stated. It requires the addressing of many issues, not the least being bringing together the multitude of stakeholders, and that is probably one of the largest areas. So that is our company group, are involved in the shaping of industry-based initiatives. We are working with a range of stakeholders, and we will lend support to address these issues. It is a very significant economic opportunity for Australia to participate in, including from the perspective of our own industry development. So, in conclusion, 2016 is a year that we are bringing to this market and across Asia Pacific large-scale and smaller-scale products from our range of voltage optimisation and virtue storage solutions. I hope that you found this overview of interest. It certainly provides you with some tools and frameworks to think about achieving zero energy buildings and all of the other operational benefits that can be derived from these systems approaches. Thank you very much.